Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Montakim. I'm editor of Robotics and Automation News.com. In this video podcast, I speak to Mark Heidebrecht, co-owner and managing partner of Ergonomics International. Mark makes a presentation at the start about his company and the broader field of ergonomics, and then I ask questions afterwards.
My name is Mark Heidebrecht. I'm a board certified ergonomist. I'm also board certified by American College of Sports Medicine. My business partner, Sam Bradbury, is also a board certified ergonomist and board certified by American College of Sports Medicine as well. And we're both co-founders of Ergonomics International. We reside in Kansas City in the US, stateside, and Sam resides in Santa Fe, New Mexico, but we really do business throughout the United States and internationally as well. And today's presentation, we're going to touch on ergonomics, human factors, and discuss how it has impacted us with the COVID-19 virus, and discuss two components that are actually very different that can be of value during this challenging time and when times get better and we're back to our more norm, if you will. And one is human factors in regards and ergonomics in regards to physical demand analysis and ergonomic risk analysis. I'm going to touch a little bit. So first of all, I'd like to give a little bit of a background slide. And I'm not going to spend a lot of time on this, but there's a lot of misconceptions out there about ergonomics and ergonomists and what we do. When most people hear the word ergonomics, they think of office chairs and they think of sit-stand workstations and they think of reducing the risk of carpal tunnel. And I don't have a current percentage right now, but at one point, a couple of years ago, in the BCPE, let me just touch on that. The BCPE is the Board of Certified Professional Ergonomists. That is the certifying body in the United States. The IEA is International Ergonomics Association, and they set the standards and criteria of who can become a board certified ergonomist. And many people, at least here in the States, that say they do ergonomics are not board certified ergonomists. They are maybe healthcare professionals that have gone to a weekend course, but they're not board certified. And every country or region will have a certifying body that meets the IEA standards. The thing that most people find interesting when I say I'm a board certified ergonomist, I travel about 36 weeks out of the year. And it never fails. I sit down on an airplane and someone says, "What do you do?" And I say, "I'm an ergonomist." They say, "Oh, you design chairs." Oh, no, I don't. I never have, and I don't really plan to. 89% of all board certified ergonomists have a PhD in psychology. And people kind of look at you funny when I say that. And what we look at is the cognitive component, how people make decisions, how people process information. And so really we have three different components of ergonomics, human factors, and user experience. And those three terms are synonymous. So the certification for an ergonomist, a human factors professional, or a user experience professional is the exact same. There's no separate test for either. And so we have the physical component, the cognitive component, and the emotional. When most people think of ergonomics, they think of the physical side over here, and they think of ergonomic risk factors, what can cause injury. What we're going to touch on today is this physical component with the ergonomic risk factors, but we're also going to talk about it from a physical demand standpoint. And those two are very different. And it's really critical that they be separate because it can create a liability situation if we don't separate those. And we'll touch on those two differences. The cognitive component looks at warnings, instructions, labels. So we have our ISO standards that talk about what a warning sign looks like. And if you think about how that's progressed, back in the day, we'd have a sign that said maybe danger. And then what we found through research was if we make that a constant color, if we're consistent in how we color those, then people will recognize it quicker and they'll be able to make a decision faster. So we went to a common color. And then we said, if we standardize the text the same way, then they'll be able to recognize it faster. And then we said, you know what, if we put a picture with it, if we put a pictogram with that image, that word, danger, then they'll be able to recognize it even faster. And if you don't speak the language, you'll still know what it means. And then we found that we make even better decisions if we don't necessarily just put a word and a picture with it, but we also put a consequence. And so that's why you'll see, a cogwheel with a hand going in it, and that tells everybody that, that's a point that we can get our hands stuck and it can cause serious injury. And so that's what the text next to it says is, what the consequence of that is. Here in the United States, and especially Kansas, we have tornadoes. And so back in the old days, you would hear a tornado warning that says, hey, there's a tornado, seek shelter. Now it says, seek shelter, this storm is known to cause this type of damage and or serious death or injury. Okay, and so those are the cognitive components. With information processing, that looks at things such as distracted driving. It looks at, I spend about a third of my time doing forensic analysis as an expert witness. And so I've testified in police shootings. Was it appropriate for officer to fire his weapon? Most people don't think of that cognitive component even as ergonomics. They don't even think it's related, where that's actually the larger component. When we look over at this emotional side, this is where people really give you a funny look. They're like, how does that apply to ergonomics and human factors? Well, one of my good friends, he works for a phone manufacturer, one of the designers. He's never been in a plant, but he designs is how we navigate through our smartphones, what the swipes mean, what the double clicks mean, those sorts of things. That's that user interface. And that's really where the new focus on ergonomics is really going, because if we get frustrated with these smartphones, if we get frustrated with the tablets that we use, what are we going to do when we have to buy a new one? We're going to switch models because we don't like the interface. We get frustrated with it. So I say that just because there's a large misconception or a narrow focus on what people typically think of as ergonomics. I think this helps broaden that and see that when I walk into onto a shop floor, I'm looking at it maybe for a physical perspective, but a lot of times decision-making processes affect that physical side. And so, if I'm looking at a process and we have injuries potentially, or maybe we have rework, when I look at rework, I look at, well, that means we have a double touch. That means someone has to touch it twice. And so why do we have the rework? Many times rework is because cognitively we can't keep up with the process. Maybe there are too many decisions that have to be made in a short period of time, which leads to a physical component. So with Ergonomics International, we would like to provide tools that objectively identify, quantify, and rank musculoskeletal risk and lead companies to solutions. And we really started this this process I'm going to walk through. I was on a flight back from New York City. I testified in a federal case, and the case went well, had a favorable outcome. And I got to thinking, why is it when I testify in court, I use one assessment process that has to meet a high standard that a federal judge will allow into court? But when I walk onto a shop floor, I use this checkbox tool that's easier, that would not be allowed into court because it doesn't have validity and reliability to it. And so that's really what set us on our journey about 5 years ago in developing these objective methods that can quantify this information we're trying to gather. And so we take an evidence-based approach to this. And what I mean by that is every question we ask goes back to a peer-reviewed journal or to a government document that has a definition tied to it. If we're looking at risk, every risk is tied to an epidemiology study. Okay, and so there are lots of checklists out there. And so if we look at evidence-based denotes an approach to medicine, education, and other disciplines that emphasizes the practical application of findings of the best available current research. Unfortunately, most ergonomic analysis tools previously are based on expert opinions, not evidence. And so if we look over at this pyramid, most tools we have now are based on those opinions and papers and experts. Now we have some very smart experts out there, so we have some pretty good checklists, but they're not necessarily based on epidemiology data. And so that's the approach that Sam and I take is, if I'm going to do an analysis, I want to be able to do analysis that I could present to a federal judge, and the judge says, yeah, this meets the criteria that I will allow it into court. So that's the approach we take with evidence-based research. Let me talk a little bit about risk analysis versus physical demand analysis. Risk analysis is what most people think of when we think of ergonomics. We think of, could it cause, for instance, carpal tunnel? Could it cause a rotator cuff injury? Could it cause low back injury? And so an ergonomic risk analysis quantifies the presence of ergonomic risk factors in terms of magnitude, duration, and frequency in relation to the development of musculoskeletal injuries. Could this risk factor cause this type of an injury? Now, the difference between that and a physical demand analysis. A physical demand analysis is different than ergonomic risk analysis in that it quantifies physical demands required to perform a job task as the job exists today, but doesn't quantify risk. Okay, and so how a physical demand analysis is used, it is used to identify what's required to do the job, and then what physical requirements does the individual need in order to perform the job safely and efficiently. And so it's used for post-offer testing, return to work, for those situations where we need to say, you know, we've made the job as good as we can today based upon our resources, the limitations of the facility, the equipment we have available, but we still have to palletize. Okay, and so our boxes weigh this much and we have to lift this many boxes a day or an hour when the truck comes in. And so we need to make sure that the person that we hire for this position can physically do that safely without risking injury. Or if we're returning someone back to work from a personal injury or a workplace injury, has the person been rehabilitated to the point that they can do the job safely? And many times the physicians and the therapists don't have the knowledge to do that because this type of analysis hasn't been done. It hasn't been provided to them. So really they're making this decision based upon maybe what the employee tells them, but not good, reliable information and data. So the software that we created is a SAS system, and it's mobile compatible, so you can do it on your smartphone, you could use it on a tablet, but it has the ability to capture the physical demands of the job, as well as ergonomic risks and other types of things. From the physical demand standpoint, we find that video or a photo can really be beneficial to a healthcare provider, a physician, or a therapist in returning someone back to work. And so it allows us to capture video, pull from that video, then still images that we place into a report, so the healthcare professional can actually see what are the positions that the person has to get into, what are the types of things they have to be able to work around. And so many times if a company does do a post-offer test or test someone to return back to work, they may just have the person, can you lift 50 pounds? Well, picking up 50 pounds, well, to what height? And are there obstructions? Are there things we have to work around? If they have to carry it, how far do they have to carry it? Providing those details so we can make sure they can physically do those aspects of the job, not just pick it up once, but pick it up how many times in what type of an environment. And it allows us to capture that information in a reliable way that's done consistently each time. So this is just an example report. I won't spend a lot of time walking through all the details of this, but allows us to capture the task. And this is just a ventilation HVAC, heating and ventilation company. And with this job, there's really just one task, which is installing the ventilation. Now, if you had an assembly task or assembly job that maybe had 2 or 3 different tasks, you can list those out and then apply those physical demands to each specific task itself. And this is what then that captured data looks like. So it captures the physical demands. And I think I'd like to point out, we actually presented this a couple of years ago in the UK at a international conference that looks at employment standards and return to work. And one of the things that I've always said that, you know, before you can measure something, you have to define it. And too many times, for instance, standing, you know, if you had asked 5 different people, what is the definition of standing? They say, okay, it's stationary, it's not moving. Okay. And if you had to say, well, it's their definition of walking, well, it's movement. Okay. Well, at what point does standing become walking? Is it, you know, if you take a side step on an assembly line, does that become a walk? If you take 2 side steps, does it become a walk? You know, if you turn around with 1 step to reach something, are you walking at that point? And so what we actually found there are definitions, we just needed to standardize them. And so we went through and have definitions for every one of these physical demands. So what that allows us to do is every time we gather that data, it's gathered consistently every time. And no matter who gathers the data, we're using the same definitions. And so, for instance, there is a difference between standing and walking. Standing is taking 3 steps or less. Walking is taking more than 3 steps. And so there's our definition. So now, every time we look at that, we see a person take 1 step over to grab a part. That's not a walk, they're still standing. Within this report, we have the physical demands, we have the task it's associated with. And so from an accommodation standpoint, if you're trying to bring someone back to work, they may be able to do 2 of the 3 tasks absolutely fine, but 1 task they have difficulty with. So that allows us to really focus in on the one aspect that we need to look at. Can we accommodate this individual and get them back to productive work? We have the description of the task. DOT, that's something that's very specific to the United States, but it's a frequently used, even in other countries, classification for jobs, and it's never, occasional, frequent, and constant, and those are basically divided into thirds. And then that's actually calculated through the frequency and duration. And so what we've found through our observation is the DOT level is probably one of the most misused calculations and misdocumented things by human resource professionals. And so we actually calculate that based upon the duration and frequency of that physical demand occurring. And then this duration of that recovery, that's something that, as far as I'm aware of, we're the only people that actually look at that. And that's really that's the endurance component of how long. So for instance, standing, we have 2.5 hours. What that means is that individual really doesn't have a break from standing for 2.5 hours, the length between maybe coming to work and the first break. And so what it shows then is that healthcare professional is maybe, testing someone to see if they can return back to work. What is the endurance of that individual, and do they have the endurance to do that job for the 2.5 hours necessary? With every physical demand, we have a photo tied to it. And so what this allows us to do is literally look at the physical demand, look at the postures associated with it and other working environments around, and actually see what are the positions and postures. So for this image right here in the middle, where this guy in this black hat is picking up a large duck to put it up overhead, we can actually see the position that he has to get into to lift. Now that's a very different posture than just picking up a crate off of a ground and setting it on the table. And so what it allows us to do is be very specific in our testing to make sure that not only can the person lift, but in this situation, that's a lot of stress on that shoulder. We need to make sure that person has full range of motion with the shoulders as well to do that job safely. We do the same thing for lifting. Show the positions and postures. Here we have lifting, and they're actually standing on ladders there in the bottom. So we can actually see, that they have to lift, but actually on a ladder. And reaching, so we can just see all the different postures associated with that. And so what that really allows us to do is it allows us to provide that information to the healthcare providers so they can make educated decisions returning someone back to work. And whether it's a work-related injury or in today's time with like COVID-19, if you're an individual that was affected by that, you may have a reduced capacity. You may have some endurance issues. And what it allows us to do is allows that healthcare professional to know that, that's something we need to focus on. That's something that we should really pay some attention to, that there needs to be an endurance component. You don't just need to be able to do this once, but you need to be able to do it sporadically for maybe 2.5 hours. Make that educated decision so that we're setting people up for success and not failure. So what this allows us to do then is take that information and develop very specific, job-specific functional tests. And so here we have a mechanic at a shop that it's actually a large foundry that makes large vessels for oil refinery, and he's one of the maintenance guys that maintains the equipment, and so here he's actually working on the wheels of the forklift. So what it allows us to do is actually replicate that posture so that we can test it specifically. There's a lot that actually, if you broke down him getting into this position, that tells you a lot about that individual as far as just movement patterns and those sorts of things. And so it really allows us to be very specific in the testing to make sure that, we can get into all the positions and postures that we need to do that job safely. And this is the testing protocol then that we put together based upon that first report, that physical demand report. So here we have the tests, how much weight they have to be able to lift. And again, this isn't looking at it in terms of could it cause injury. We're looking at the job in terms of here's how it exists today, and can you do the job safely with minimal risk of injury? And so these are the different jobs. These are the able or unable. So the therapist or healthcare professional will basically check, are they able or unable to do the test or do the physical demands, the test protocol. And then this is just an example, the mechanic circuit on the side. It shows standing and balancing, working on an incline, squatting. It shows laying on the side and doing a step ladder. So this is like a circuit test that then we could put the individual through to make sure they could get in and out of all those positions and lift the required loads. How is it used? Well, as I mentioned, it's used for return to work. Physical demand analysis should be used to develop effective functional test protocols for effective return to work after a cumulative or traumatic injury that's work-related or non-work-related, as well as after any significant event or extended illness. And so, for example, I have an individual who was unable to complete one of these tests. And so what I provided them was, these are the areas you struggled with. And so here's some things you can do. If this is a job that you would really like to have, here are the steps you can take to increase your endurance and strength so you can come back and do this job safely. It can also be used for new hire. So after an offer, and this varies by country as well, based upon laws. But in the U.S., after an offer has been made, you can test an individual to make sure that they're physically able to do that job. And it's no different than denying employment based off of a drug screen. If you offer the person a job contingent upon them passing the drug screen, and they fail the drug screen, you can deny employment based upon that. In the U.S., same goes for functional testing. If you make the offer to hire an individual based upon them being able to complete the physical demands of the job safely, then if they can't and there's not a reasonable accommodation that can be made, you can then deny them employment. And so this will provide you that documentation you need to show that, but it also provides the documentation you need to say, here's all we need to do to accommodate this individual. It makes that accommodation process much, much easier. So we talked about the physical demand piece, which is this far right-hand one over here with the dark blue tab. Now I'm going to just touch on the risk piece so we understand how that's different. And I think this actually, in today's environment, may actually even have more applicability to especially what we're talking about in this presentation with automation and robotics. And so with the risk analysis, again, what we're looking at is, could it cause injury? And so we've taken, I guess what you could say is a non-traditional approach, in that most ergonomic checklists, as I mentioned before, are based upon expert opinion. Well, expert opinion isn't always good enough to make it into court. You have to be able to show why your opinion is relevant and correct. And so this is where, like I said, about 5 years ago, I was coming back from this case and I was like, why is it I use these two different methods? And so Sam and I started to gather this data. So I pulled some of these reports that I wrote for federal court. I said, well, here's what I cite. Here's the epidemiology data that I look at. Okay, and so in today's environment, we actually hear quite a bit about epidemiology in terms of COVID-19. Okay, and so what we're looking at with epidemiology data is we say, if this risk factor is present, it has this much of a likelihood of causing an injury. And that likelihood is calculated on an odd ratio. It's actually a calculation. It's the same odds we use if we go to the casino. And so what it allows us to do is literally give us a % chance of an injury based upon a risk factor being present. Okay, and so to give you an analogy, what it may be is, look at hand washing in today's environment. How much does hand washing reduce the likelihood of getting COVID-19 or some other type of flu? And so there would be epidemiology data that states that if we wash our hands, the chance of getting COVID-19 is reduced by this much. And so what it allows us to do is make good informed decisions. If we think of that in terms of today's environment, we're like, well, hand washing is pretty easy, doesn't cost much. That's something easy to do that we could easily implement to prevent the risk of injury. This gives us that same tool in the workplace. We can now look and see what the odds are of getting an injury, and then what we've actually tied to it. And we can do this based upon national guidelines, or we can do this based upon company guidelines. We actually tie that number to an actual injury. How much does a carpal tunnel cost? How much does a low back injury cost? And use those odds to actually calculate what are the dollars at risk. And so it gives us a real number for management to make good decisions off of, rather than, was this box checked? Now, every question that we ask has an epidemiology study tied to it. And so there isn't a question that we ask that isn't tied to an epidemiology study. And what we found was there's a lot of questions out there that traditional ergonomic tools ask that don't really have much they don't really have much as far as the science to back what is being asked. And so that's really why we've gone to this approach. It allows us to take a evidence-based approach and base our decisions on real epidemiology data, not just because I think this is a good thing to ask. What it then provides us is, this is one of the dashboards, and the dashboards are customizable based upon what you as a facility find valuable information. One thing that there's a book I read that was 7 Disciplines of Execution by one of the authors was Stephen Covey. And he talks about people make better decisions when they're make better, or they're more engaged and involved and make better decisions when they're provided the information, and when when they have involvement, if you will. And so and they're playing with something that matters. Basically, you play differently when you're playing with something that matters. And so if one measure doesn't mean anything to you, then that's a terrible measure to use to base decisions on. So we need to find what matters to each individual. So they can actually customize those dashboards however they want. But then this actually down at the bottom here, this average odd ratios, this actually shows you then the % likelihood of an injury based upon the risk factors that are present. We can break that data down specifically by line, by task. We can actually break it down if a company wants. We can break it down by product made. We have a medical device company that we work with, and they wanted to be able to break it down by product made because there were certain products that went to certain countries that were much more difficult to build. For instance, I believe the unit that went to Israel had many more tubes and things to attach than the ones that went to some other countries. And so that build was much more difficult. And so what allowed us to do was actually gather and quantify the risk of that build and compare it to other builds. What that allows a company then to do is actually make decisions from a based upon data and information that says, you know what, this is what's in our queue as far as production, but we don't want 2 really hard products back to back. We want to make a build in there that's an easier build to give some recovery time. So it actually assists in the decision-making process of the order that we can build things, because we can actually see, you know, is this a good strategy, or do we need some other build in there to give that body recovery to keep our workers healthy and productive? We can also look at it by line, because everything's gathered by task. We can use that to develop job rotation strategies. So we don't just rotate down the line, but we can actually see that, you know what, if we skip over this one position and then come back to it, then that provides a recovery cycle as well. So that we get those recovery cycles in, so we don't stress those body parts that may be at risk. And really the key to this whole thing is coming up with solutions where we do have risk. And so in many cases, what we've found is traditional assessments may overestimate the risk. They may say there's a risk where there really isn't one. And so we're able to flush those out and get those out of the way so we don't have to stress about those. But then what it allows us to do is then provide solutions. And so if there are devices, manipulators, cobots, things like that that could be used to then reduce the risk or exposure, then we provide solutions then for people. So based upon the questions that are asked and how they're answered, we then provide a solutions table for individuals so that they can, they know what's available. People don't know what they don't know. And so if you provide solutions, they can at least start that creative process of problem solving. And as I mentioned before, the whole process is mobile compatible, so it can be done on a smartphone, it can be done on a tablet, lots of different scenarios as far as how the data is captured and utilized. One thing that I've found after doing this for 30 years is the data gathering process isn't usually difficult. That's actually the easiest part. It's actually doing something with the information after we gather it. And so that's why we provided the solutions database. That's also why we've made it so that it's mobile compatible, so that literally once you're done gathering the data on the shop floor, your dashboard is populated. You can now start making decisions. You don't have to go back and enter information into a computer program or start crunching numbers in an Excel spreadsheet. That work is already done. And by using risk analysis to prioritize automation, it reduces the exposure to employees. So with this medical device company, one of the things that we did with them, we were able to go through and say, here are the workstations with your highest exposure. And if we could just implement 3 cobots on a line, now we've reduced that exposure by this much. And now you've made a very hard workstation an easy workstation, which is now, this was a risky station that could cause injury or contribute to injury. This station now you're just feeding the cobot or feeding the trays for the cobot. And so now that becomes a recovery cycle. It allows us to quantify that. And it shows that, you know what, we don't have to necessarily automate the entire line. But if we just do these strategic 2 or 3 workstations, it reduces the risk by this much. And that's much more easy for management to swallow. And then it allows us to then say, you know what, maybe next year, next budget season, these are the other 2 positions we want, and we can reduce the risk by this much. So it gives us a way to quantify the results, objectify them, and develop a plan that can work with the manufacturer's budget. So that's my presentation on ergonomics, human factors, and the software that we have developed.
Thank you very much, Mark. That was a very interesting presentation about a subject I've heard about, and I would probably be one of the people who would say, you know, or assume that you design office chairs or something. So yeah, I'm sort of ignorant position. But yeah, it is really interesting. I particularly like the list of physical movements or physical motions. It's a very long list: standing, walking, you know, bending sideways, and so on and so forth. It's quite eye-opening that, and of course, it stands to reason that there are regulators. You mentioned Europe. I'm sure there's equivalents in US and everywhere in the world, especially advanced societies where industrial work and environments like that are covered by laws and regulations and insurance, you know, agreements. So it's yeah, it was very, very interesting. So I have a few questions, if you don't mind. I'll ask 1 or 2.
Absolutely.
Yeah. Okay. I don't know which one to ask first, but I was a lot of the things that you talked about, I think almost everything that you talked about was involving a human, you know, how the human moves and how the human is, you know, behaving in an environment. And yeah, as I say, you've gone into very great detail about that. I maybe be able to think one or 2 questions about that. But I was wondering if you ever do the type of work that involves looking at products and how ergonomic they are, or facilities and workspaces, inanimate objects rather than humans. Is that something that you ever do or get involved in?
Absolutely, absolutely. Yeah, from a product design standpoint, that is another subgroup or an area of ergonomics looking at, and that's really, if you really want to talk about, you know, what the ultimate goal is, the ultimate goal is designing it for easy and efficient human use from the beginning, whether that's an assembly line or whether that is a product that you use. You know, the simplest things all have ergonomics built into it, whether you know it or not. In fact, you know, we have a water bottle right here. This water bottle, the size is developed so that a 25th percentile female can, which is a small female, can wrap her hand around the bottle and hold it efficiently without a lot of discomfort or straining or things like that. So the simplest things, you know, the height the chairs adjust to is based upon anthropometrics and ergonomics. And so, yeah, absolutely. When you look at it from a design standpoint, that's really where I like to get involved, because you can design it right the first time, and it's a lot more efficient and cost effective to do it, to put the effort in on the front end than on the back end.
Right. And you mentioned a couple of times actually about courts and you know, expert opinion and versus evidence, or in contrast to evidence, which I found quite interesting. Yeah, we've probably all seen dramas and films where experts are brought in to give their opinion, and it's accepted sometimes, but you're saying that it's probably not going to be accepted if it's, especially if evidence is available, science-based evidence. And ergonomics, as I just read online, that it is a science, a multidisciplinary science. So yeah, how often do you get asked to contribute your evidence to court? I don't know how to put it. Giving evidence in court? How do you actually phrase it?
Yeah, no, absolutely. And so I've been designated as an expert witness in over 80 court cases. And so here in the United States. And so, and that includes state and federal court, which there's two different levels there. And with federal court especially, there's a certain standard that has to be met that the judge then will rule and be either admit or not admit your evidence into court. And so that threshold is set by numerous court cases that have occurred previously, but is based upon good scientific and sound. One of the most knowledgeable or knowing, I guess, court cases is the Daubert case, which is a pharmaceutical case, I believe. And what it basically said was, this is the level of knowledge and expertise and scientific validity and reliability that has to be met in order to be allowed into court. And that was one of the first cases that someone was basically not allowed to testify based upon them not being qualified as an expert. And so that was really, I mean, if you want to talk about kind of that aha moment for Sam and I, when we were coming back and I was talking about that, I remember calling him at a layover in one of the cities that I was flying back through, and kind of bouncing this idea off of him. And then we started working on it after that, was that, you know, why is it that we use these two different methods? One, which is a simple checkbox, and there are lots of those ergonomic assessments out there, some very well-known ones, but when you actually dive into the scientific background of them, they're not real solid. There isn't any epidemiology data. In fact, some of the motions that are captured don't even apply to the body part that they're being grouped with from a biomechanics standpoint. And so there really are quite a few flaws out there. And so we've really tried to bring much more of a scientific background and provide validity and reliability to our analysis process.
Right, Mark, I'm sorry about this, but when I finished asking the question and you started speaking for a good minute or so, the line was so bad that I didn't hear what case it was. So if you don't mind repeating it, I know it's being recorded to the cloud and maybe I got a bad line, but the cloud actually got you clear. Yeah. But yeah. I just want to make sure that I've got you saying the first minute or so, saying what the case was in the background. The rest of it was recorded.
Yeah, was it where I was discussing the Daubert case? Is that where it was, or was it before that?
I didn't hear the Daubert, definitely didn't hear the word Daubert, yeah.
All right, ask me that question again so I get a fresh start on the question.
Okay, then. All right. Good idea. I didn't want to do that, put you through there. But yeah, how often are you asked to give evidence in court? And you give us an example or two of the kind of work that you've done in that area.
Sure. So I've testified in over 80 state and federal cases, and those are just the ones that I'm named as an expert. I've actually testified in many other cases, provided testimony or reports in many other, probably 100 more cases, where a client has said, "Hey, we're challenging this being classified as a work comp case or something that we caused." I probably testified in more than 100 of those, but the ones that I've actually testified in court, been deposed on, were around 80. And that was really that aha moment that Sam and I really came upon this process and started questioning kind of the traditional methods that many people have used in ergonomics. And we started to say, we need to really look at the tool we're using, and can we provide a tool that's actually more valid, that actually gathers epidemiology data, and that we can point to and say, this is a risk factor because this is present and your chance of an injury increases by this much. Not just that we checked a box in a checkbox, which if you look at some of the traditional ergonomic assessments, some very popular ones out there, there isn't a lot of validity and reliability validity and reliability. Let me just clarify. Validity is, does the test what it's supposed to? Reliability is, can it be reproduced with the same results? And so from a validity standpoint, we question, are these really valid tests, in that do they really test the presence of a risk of developing a musculoskeletal injury? And what we have found is, for the shoulder specifically, there are a lot of movements and motions, and some that aren't even captured, that are risks that aren't being gathered, or they're being applied to the wrong body part, maybe the elbow, because that's where you see the motion. It's but the true risk is to the shoulder.
Typically in these cases, I don't know if there is a typical case, but who is the defendant and who is the plaintiff? Or I don't know if you use those terms in the US, but who are the arguing parties?
Sure. Very good question. So I'm actually very well divided. I would say I'm about half and half, actually. Maybe as far as the cases that have been a named expert in, probably maybe 2/3 to 1/3 ish, just because plaintiff versus defense. But I really try to stay non-biased, and there are cases that I will turn down from the standpoint of ethically. I feel there's nothing that I can say that's going to be of value that is going to be for the individual that has asked me to represent them. So whether it's defense or plaintiff, I can look at the case and say, I don't think this is legitimate. I don't think that anything that I'm going to say is necessarily going to help your case. And I will just defer them and say, I'm sorry, I don't think I can help. But I'm about 2/3 to 1/3 plaintiff versus defense. If you look at all the reports that I've written, including the ones for my clients, I'd say it's very easily half and half.
Right. So typically it would be a worker who's got injured that sues the company, or the company or the government. I mean, who's suing who, or what?
Sure.
The kind of, in the abstract, in rather than specific companies or specific individuals, what kind of, who are they? Who are the people who do what to?
Very good question. So it can be multiple. For many cases, it could be the plaintiff. And so I had a case. This is actually refers to a little bit more of that cognitive piece. But I had a case a couple of years ago where the individual was scalped. She was working in a printing press. that had large rolls of paper running through it. And this company, they're actually making bags that had 3 plies of paper, and there's a little glue tray it had to run through in order to fix the glue to the paper so you could make these 3 plies. And they automated that auto glue tray filler, and the sensor they used wasn't probably the best, and it would cause the glue tray to overfill. And so in that case, this machine had over 90 warnings and labels on it, stating all, and guards. It was very well guarded. However, the one part for this glue tray was this piece of equipment they basically pulled out and stuck a new piece in, did not have a warning, did not have a guard. And so my testimony in that case was actually that it gave a false sense of security, in that the machine, it appeared, had warnings at every location there was a potential hazard. And so her perception was that was a safe place for her to go because there was no warning, there was no guard. And so that's an example. And her hair got entangled in the equipment and she was scalped. Fairly young individual, mid 30s. And so she had a disfigurement that was life-changing. And so in that case, I testified for the plaintiff. And that was actually, you asked the question earlier about design. That was actually a case that we went back to the designer of the equipment, and it wasn't the actual company that was using the equipment, but it went back to the designer of the equipment, because they were a designer or a manufacturer of manufacturing equipment is supposed to be able to create a product that is safe to use and doesn't present danger. And that was not the case in this situation. And so in that case, it was for the plaintiff. Now, for many of my clients, I will analyze a job task that maybe an individual has claimed a workplace injury, and I will analyze it from the perspective of are the risk factors present that we know could cause or contribute to cause this type of an injury. And if it's consistent, then I'll tell my client that, you know what, this actually is a risk, and we need to work on minimizing the risk. We need to work on reducing the hazard so we don't hurt someone else. And this is a situation that you bought this injury, if you will. In other situations, I'll look at it and say, you know what, the injury they're claiming is not consistent with the ergonomic risk factors that are present for this job, and this job is not, could not have caused that type of an injury. And in that case, then I'll write a report then to defend the client and say that, you know what, there's inconsistency in the risk factors that are present and the type of injury that was that the individual had.
Kind of thing for 30 years. I find anybody who's done something for 30 years is quite it's a bit of an achievement. What changes have you seen, if any, at all, in terms of what kind of activity or accidents or design flaws or design advancements, even positive things? Is there a pattern? Are there patterns that you've identified over periods of time?
Yeah, absolutely. I think one interesting, in the U.S. and most industrialized companies or countries rather, I think the trend is that traumatic injuries are going down. OSHA is our regulatory body in the United States, and what you see from a trend, and I have several clients that are insurance companies, and I've looked at their data as well. What we're seeing is traumatic injuries are going down. You don't have as many traumatic injuries, and you don't have the severity of injury typically. Now you still have those injuries that just shouldn't happen, but and due to air, due to design, lots of different things. But in general, most traumatic injuries are going down. What is not going down, or what's the larger percentage now, are the musculoskeletal injuries. And on average, for most companies, manufacturing environments, most of the injuries, about 70% of their injuries are musculoskeletal related, involving either upper extremity, fingertips to shoulder, or low back. And that's really the trend now is, and that's why this is so much of an emphasis now, is because companies have done a pretty good job of eliminating the risk of those traumatic injuries. Now what we have to do is work on reducing those musculoskeletal ones.
Right, and the trend in robotics, I'm sure you know, because you already mentioned cobots, collaborative robots. As you know, most of our audience will know. I'm just mentioning it for new people. Robots, industrial robotic arms, those big machines that do welding and all sorts of other things. They used to be caged off and kept away from human workers because of the risk of injury, because they're such powerful machines. But now the smaller robots, those arms, collaborative robotic arms, I think they call it. Yeah, they are supposed to be safe to work with for people. Is that something that you've got a comment on, or is that something that you notice being making a difference to the workplace? Is it getting safer now as a result of things like that?
Absolutely. I think cobots are literally a game changer in that, there's certain things that humans are good at and meant to do, and there's certain things that should be automated because we're not necessarily good at them. We're not necessarily, humans aren't necessarily built to do the same movement pattern over and over and over and over again with consistency without error, whereas robots are, cobots are. That's what they're designed to do. That's what they're good at. And so, I think those are the situations that I look at, particularly when I go into a manufacturing environment, are what are the things that people are doing that could be done more efficiently and or safer through automation, whether it's a cobot, whether it's just an automated process. And what are the things that people really should be doing because we're better at doing that than a robot, things that have variability. I spend a lot of time in food processing, specifically meat processing. And that's an area that's been difficult to mechanize because there's so much variability in the cuts of meat and the products that are being processed. And so that's been an area that's been lacking that automated process, but we're getting better. We're making progress there. But where I really think there's a lot of opportunity in the near future is that interface with the cobots. And from what I've seen, my experience with them on shop floors is, and I think Abdul, you phrased it very well. Back in the day, we had these very large robots that welded, and they moved fast, they moved quickly. You had to have them caged. And I worked with several first and second tier manufacturers for auto industry, and sometimes guarding becomes an ergonomic issue. Our safety guarding that are trying to prevent injuries actually can contribute to injury because we're restricting where people can go. And so sometimes they have to twist, bend, overextend because of that guarding. Whereas with cobots, we can get right up with them, interface with them, and they do move at a slower speed, and they do have these built-in stops to where if a force is exerted, if we get in within a range that we shouldn't be, then they shut down. And so I don't have any personal experience at all. I've never been contacted about a case that involved a cobot causing injury.
Right. Right. Finally, what future direction do you think your business will take? Do you have any plans based on maybe new issues that you've noticed, new technologies that you might have identified, or anything that you can think of that might change or add something to your work over the next few years?
Sure. I think I think COVID-19 has caused many small businesses to and manufacturers, large businesses, as far as that goes. I would say this epidemic has really caused all of us to look at how we do things and be creative. And you know, I've I have several food processing companies that I've been working with, and manufacturers, as far as that goes, that I've been working with during this epidemic, um, you know, from my office. And just because, especially the food manufacturing facilities, they started in the United States. I started to be limited on access to them back in February, which is actually before a lot of the quarantining started here in the States. And just because they wanted to make sure that food supply, that food chain was being maintained. And so they started to limit who was coming into those facilities. And so, which is smart. But I've been able to do many things remotely where I can coach someone. Hey, this is the data I need. If you can get this video for me and then upload it to a cloud, then I can pull that video and analyze it. I may have some questions as far as repetition rates, units produced, but I can still do many of those analysis. So I think what it's gonna do is going to open us up to potentially doing more things remotely, um, and uh, and and through mobile devices, where I may not need to be on site as much, but may be able to coach someone or someone with some limited training to gather the information I need to make those reports and decisions.
Okay, thank you very much, Mark, for a great interview and a great presentation. Thank you for your time.
I appreciate it, Abdul. Thank you.
I'm just going to stop recording. Hopefully that'll be...
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.